My name is Colin Belveal. I'm here with Chris Thrower and Matt Hardin. We're going to be doing an RC car presentation. We are all students here at Oklahoma State University Institute of Technology. Here's an introduction of what's going to be presented in our report. It's first going to be work performed with software, hardware, and wiring, and then go into a flow chart, project logic, communication, problems encountered, dead zones, manual mode video, as well as an autonomous mode video.
Hey guys, my name is Matt Hardin. Software used was LabVIEW. LabVIEW read the inputs from the joystick. The Arduino was used to take the inputs from LabVIEW. There were DC motors used to control the car. There were 4 ultrasonic sensors for automatic mode, and then a 433 MHz transceiver was used for wireless communication.
This is Chris Thrower, and this is the flow chart. You can see that there's a joystick that communicates with the LabVIEW in the computer, and then it goes to an Arduino Uno and the transceiver, which sends communication to another transceiver on the bottom of the screen, where you've got an Arduino with a motor driver shield that communicates to the RC car with 4 ultrasonic sensors. The project logic of the actual software begins by reading the joystick, and it determines whether there's an auto or manual switch on. Then it processes the directional input, which moves the RC car and reads the joystick again. If it's switched to auto, it begins to read the ultrasonic sensors and then ignores the joystick, processes what the sensor tells it, and moves or stops the car based on that, and then reads the joystick again. It just starts all over.
Okay, so now I'm going to discuss some of the communication that was used. The LabVIEW was used to send a value between 0 and 180 using a servo write command. The Arduino then received this value, but the value received was between 0 and 2410. As you can see on the left-hand side of the screen is the front panel from LabVIEW. A 67 was the angle being sent, but on the right-hand side of the screen, the Arduino was receiving a 1256. As you can see again on the right table on the right side of the screen, the 67 resulted in a 1256. This in turn sent the motor in the forward direction.
Here's our problems encountered and how we overcome some of these problems. We were going to use 2 transceivers, but the second transceiver that we ordered was sending trash values, so we only used one transceiver by using a constant speed and direction. We were able to fix our front gear issues by tearing down the front end and fixing the spring that's inside there. Also, we fixed the current limitations from the 9-volt battery by ordering an actual RC car battery from the internet, which enables us to get more power out of the battery. And also, we fixed the cracked bowl housing by gluing it together and letting it sit for a week.
We also have some current problems that we're trying to work through. The one transceiver we are using occasionally loses communication, so sometimes communication is dropped and the car acts out. There's also a low turn radius due to the front gear issues on the car, and there is a dead zone between the sensors, as Chris will talk about on the next slide.
These dead zones, if you look on the picture, it's able to detect it in the blue areas and cannot detect anything in the yellow areas. That's because the sensors measure about 15 degrees directionally, and the car frame can only handle a limited number of sensors, and so we can't put as many as we would like to on the car to get it to operate the way we would like. Here I'm just taking the joystick and I'm moving the car and pretty much doing what I want to with it here, going backwards and forwards. Some of the places you can actually see the transceiver lose communication. That's just one of the problems we have with it.
As you can see, this is the basics for the automatic control. When an object is placed directly in front of the car ultrasonic sensors detect it and avoid the objects. When it detects an object, it tries to go left, but if it is unable to go left, it will back up and then go left to give it enough room to miss the object. Coming up, it will go between a chair and it will exhibit both left and right controls. The ultrasonic sensors on the left and the right side were used to detect the chair. As you can see in that picture, the dead zone, as Chris talked about earlier.
Here's another example of the autonomous mode. You can see it again backing up and adjusting its movement. It makes its way under the table Again, you'll see that front sensor, and it backs up, tries to turn left again to avoid. This video was created by Chris, Colin, and Matt, and we hope you've enjoyed it.